Hello and welcome to the restart of the API trainings. I'm very excited to have you all here. My introduction would be very short. I'm Christina, I'm the product specialist for Dimensions, and I'm only here just to learn and listen, just like the rest of you. But the main star of the show is my colleague Michele, and he will be running through some of the BigQuery highlights for today. And this will be recorded and available to you. Feel free to ask questions, and we will try to answer as many of them as possible. And with that, I'll just give the floor to Michele.
All right, thanks very much, Christina. Let me try and share my screen here without messing things up. That's not what I wanted to do.
I think it should work now.
Oh, there you go. Yeah. All right. Can you see my slides?
No, but we can see Slack.
Okay, so that's not what I wanted to share. Hold on. I need to show my. How about now? Still Slack? This has to be the slides then.
Yeah.
Lovely. Okay, fantastic. All right. So, oh, fantastic. I can see a bunch of you are there already. I was going to say I added the link to the slides to the chat. So if you just open up the, is it called chat here? Yeah, it's the chat, it's the webinar chat. So if you open that up, you'll see a link and that will take you to the slides. So you'll be able to follow a bit better what I'm saying. And then in the slides, there's also links to other resources I'll be talking about today. So yeah, it's great to be here. We're starting again this training sessions, and which are now called, I think, if I remember correctly, Advanced Analytics Using Dimensions Data. That's the name of the series. We're going to have several lessons, and today we'll be looking specifically on dimensions on Google BigQuery, what it is, how to get started with it, and in particular, how you can move to it or use it in conjunction with the API. I know some of you have been following us a few months ago, the previous series of trainings, and we talked primarily about the API, the Dimensions DSL, Dimensions Search Language. So for those of you who are already familiar with the API, we'll be having a look at the differences between the API and Google BigQuery, and in particular, how to make the most of both platforms. So as Christina mentioned, my name is Michele. I'm the head of data solutions. And right, so this is the outline for today. So I'll give you a bit of an overview, very briefly, about what dimensions is, and in particular, what dimensions of Google BigQuery is. Then we look at how to test dimensions on Google BigQuery, in particular using the COVID-19 dataset. That's a dataset that we released publicly a few weeks ago. The COVID-19 data in dimensions, they have been public now for several months. Previously, well, actually, even now, you can access them using the web application or as an Excel download. So as soon as we release Google BigQuery using dimensions data, we also made a version of it containing only the COVID-19 dataset. So that's a public dataset, as I mentioned, so it's a perfect candidate if you want to try out dimensions on Google BigQuery without having access. Without paying for the actual product. Right, and that's number two, the second topic for today. The third one, we'll be looking at the API and how to work with the API and Google BigQuery together. Right, so I assume many of you, if not most of you, know what dimensions is. I'm just going to say it anyways for those of you who are not very familiar with it. So dimensions is a very powerful linked scholarly information platform that supports discovery, analytical, and research management tasks. So dimensions brings together a number of different research objects within one single platform. We have information about tons of publications, 110 million and counting, grants, data sets, patents, policy documents, researchers, clinical trials, But really, the added value of dimensions, the way I see it, is the fact that we have lots and lots of links in between all of these different objects. And of course, using the web application, the web UI, you can do a lot. You know, the web UI caters for a very large range of use cases, and you can do lots of analytics using it. But really, if you want to take advantage of this data in any ad hoc way you can think of, and specifically in order to match your settings, your use cases, you want to get to the actual, data underlying the web interface. And so there's different ways to do that. One way is the API. The other way that we recently launched is Google on BigQuery. Sorry, dimensions on BigQuery. So as I mentioned, that gives you direct access to all the underlying data you can see via the user interface. You don't have to do anything. You just access Google BigQuery and all the data is there. You don't have to load it yourself. We take care of that, and you can simply query the data and build applications on top of it. So let's do one step back and maybe clarify a little bit what BigQuery is. Those of you who who had never heard about it. So in a nutshell, it's a cloud data warehouse. So it's a cloud product, meaning that it totally runs on the cloud. The Google guys, they essentially manage the infrastructure. We just have to pump the data into it. And we do that every day, the dimensions data. So it's cloud-based, and it's a data warehouse, meaning that it's really optimized for dealing with large amounts of data, and large amounts of data, which is also very highly structured and very diversified. And you can query this data very, very fast. And so it's really a top product for advanced analytics, and it really suits itself very much to the dimensions use case, because as I mentioned, we have different data types, we have lots and lots of links linking together the different objects we have in dimensions. So by using BigQuery, you can really take advantage of all of this embedded semantics we have in our database. One thing to point out is that BigQuery, well, it's fair to say that it's your product. We essentially give you access to BigQuery. Once essentially you get an account, you can see the BigQuery data we put into Google BigQuery, but fundamentally you access it using your own account. What that means is that the moment you do that, you kind of establish a relationship with Google BigQuery, with the Google Cloud infrastructure, meaning that you can put other data in it if you want, and also meaning that you'll be charged for the queries you make. So it's a little bit different from the API, because with the API, we give you access, you query it, and you can do that as much as you like. With Google BigQuery, you need to keep an eye essentially on the queries you make. It's actually super cheap based on the actual things you do. It will be fractions of a cent for a query. So, that's a sort of a cost you'll be looking at. But also you have to remember that those are queries that you are charged for. Now, Google gives you a free quota for your queries. I don't remember how much it is, but it's around maybe a terabyte. It's large enough to actually do a lot of testing. And also actually probably to do some real world applications. But if you want to move to Google BigQuery in a production way, you of course have to set up an account with Google and look at that side of things as well. Now, the added value of having a cloud product is that sharing these data sets has become extremely easy. So it's a little bit like sharing a Google document. You can build a database the same way we did with dimensions, and you can simply give access to different people. So what that means is that on top of the dimensions data set you might be accessing, you may build a separate data set using your own institutional information or some other corpus of documents which is private that you only can see, but then you can decide to share that with trusted colleagues together with the dimensions access, something like that. So essentially it's very easy to build together a network of data sets you want to use to perform some sort of analysis. And finally, it's a data warehouse, but it uses ANSI SQL for performing queries. So SQL is a standard for relational databases primarily. So many of you, many data analysts, many people who have done analytics in the past, they will probably know SQL. So that's a really That's a really nice thing, because essentially a lot of people will be able to leverage their pre-existing knowledge with Google BigQuery as well. So how does BigQuery fit in within the say dimensions range of products? So the web app on the left-hand side, as I mentioned, it supports a number of different use cases. We would say the top analytical use case. Of course, when the web app was designed, we looked at what are the most common operations, the more common types of analysis people want to do. And so the functionalities of the web app, they let you do that and much more than that. However, if you want to perform some more ad hoc analysis, you want to get to the actual data and then do your own, build your own visualizations or your own dashboards, then you want to move a little bit to the right hand side and look at the other three data oriented products we have. So the API allows you to perform ad hoc analysis. It's kind of built on top of it's similar to the web app in terms of functionalities, and primarily it's really good with full text search. Yeah, the API essentially allows you to search within the full corpus of documents in dimensions by looking at the full text. The API, however, doesn't perform so well if you're building some really large analysis. So for example, if you're looking at creating some statistics for all publications for a research organization and maybe compare the statistics with the publications of another research organizations, you're probably looking at hundreds of thousands, if not millions of objects. And so building this analysis with the API can be done, but of course it will take some time, because you normally have to pull the data first into some local system, a database or in memory, and then run the analysis. And that may take hours, in some cases. So that's the main limitation of the API. So for that reason, the API is primarily suited for integrations with some software or some system where you don't have to pull a lot of data. We're talking about thousands or maybe a few tens of thousands. And in that situation, it's actually pretty good and really a really efficient way of deriving statistics from dimensions. So now Google BigQuery is different in the sense that the kind of analysis where you have to process millions, if not tens of millions of records, can be done in seconds. Super fast. It's a little bit like thinking of the whole of dimensions at your fingertip within a relational database, really, because you can query it with SQL. So you can simply say, give me all the publications from this organization, check the average citation ratio, compare it with the citation ratio of another organization, and produce some results. That would, run in seconds or even less than a second. And of course, with the API, that might take you hours, if you have to pull the data first. So that's the main advantage of Google BigQuery. So these very large analyses are very fast. And the other main advantage of Google BigQuery is that since it's cloud-based, you can put your own data also in the cloud. So it's a perfect candidate for if you're thinking of putting together a larger ecosystem of resources that live on the cloud. And since they live on the cloud, it's also very easy to reuse this data within other tools, in particular, business intelligence and visualization tools, such as Tableau, Click, Power BI. So all of these tools, they have a BigQuery connector, meaning that they know how to pull data from BigQuery in real time. So that allows you effectively to build many of the visualizations you see in the Dimensions web app within a tool like Tableau or Power BI, very easily. And we got tons of tutorials about that. I'll show you that I'll show you where they are in a second. And finally, we have the bulk data. I'm not going to say too much about this, but fundamentally with the bulk data, you would get the raw JSON data behind BigQuery, behind the API, and behind the web app. Of course, if you get the bulk data, you are in charge of putting this data somewhere if you want to make use of it. So that essentially is addresses a very specific use case, which is if you have already an ETL process in place, if you already have some data pipelines that are capable of pumping in dimensions data, which is a pretty large data set, then bulk data might be what you're after. Right. So just to sum it up, dimensions of BigQuery, what does it mean in practice? Ultimate flexibility. Any kind of query you want to ask about the dimensions data, you can do it very, very fast. It's also pretty agile because you can, change, the SQL language allows you to achieve a lot. With the API, we built our own language to make it simpler for people to perform operations on the data. With SQL, it can be simple if you have simple queries, but you can easily have some extremely sophisticated queries simply by digging more into the features of the language itself. And finally, interoperability with other platforms and data. That's another key aspect of Google BigQuery. We built a number of dashboards that to exemplify how you can connect to Google BigQuery, to dimensions on Google BigQuery using business intelligence tools. The COVID-19 report is something which is fully publicly available online. That's at the address here, reports dimensions AI/COVID-19. This is using actually the free COVID-19 dataset. So if you're interested, you can actually try to rebuild the whole report yourself using Google Data Studio, which is also a free product. So that's a really good way to get started with the dimensions of Google BigQuery if you're interested in that. So as I mentioned, you can use a number of visualization tools and BI tools, things like Tableau, Plotly, Click, whatever you can think of. It probably already has a connector for Google BigQuery. So here I have a couple of links just to show you where things are. So by going to this COVID-19 link, you will find the COVID-19 dataset on BigQuery. So BigQuery, I should say, is part of a larger environment called Google Cloud Platform. So if you want to get started with BigQuery, you need to have two things really, which is a valid Google account, a Gmail address. That's probably it. And then you need to create a GCP, a Google Cloud Platform identity using that Google account. Now the specific steps on how to do that, I'm not going to go through them today, but if you go to the documentation for dimensions of Google BigQuery, you'll find lots and lots of information about how to do it. It really doesn't take long. You can probably get done with that in minutes. So here there's lots of information about how GCP is structured if you really want to get into that. But if you just want to get your hands dirty or try and run a few queries, I would strongly suggest you to take a look at this recent tutorial we created, building a COVID-19 dashboard using Google Data Studio, and specifically the first section about accessing the dataset contains a couple of videos here that will show you exactly what the steps are to set up an account on GCP. So back to my slide. So we've seen the COVID-19 dataset grid as well, the Global Research Organizations Identifiers Database. That's on Google BigQuery, and that's another public dataset you can make use of in case you're interested in reusing that data. The dashboard here, the COVID-19 dashboard, is probably a really good example of what can be achieved by having Google BigQuery as a backend. Of course, you could probably build something very similar by putting all the relevant data into a database somewhere and then building a dashboard on top of that database. That's of course another approach to building this sort of end products. But by using Google BigQuery in the cloud, and in this specific case, we're using Data Studio as a visualization tool. We didn't have to do any of that. We simply connect to GBQ. We have a couple of queries. I'll show you the queries in a minute. It's fundamentally one query per report page, one query that pulls all the publications data, for example, and then we can, in real time, essentially process the data and build all of these visualizations within this tool. And as you can see, there's lots of information about open access, specific publication details. And since we have a live connection to GPQ in the background, all of this is actually live and in real time. So what that means that if I, for example, select here the last couple of weeks, the whole dashboard updates. It tells me, we had 20,000 publications on the COVID-19 topic in the last couple of weeks. and all of the other statistics are also updated. So for example, I could click on China here, and I might want to look just at the publications that have authors affiliated to China. Down here, there's more details about specific organizations the authors are affiliated to, the journal titles, and so on. So for example, if I select the Chinese University of Hong Kong, so I'll keep drilling down into my data set. And eventually, when this finishes loading, I can scroll down here and I can actually see the list of publications I'm looking at. So these are publications the last couple of weeks from China, specifically from Hong Kong University. I can, follow up by clicking on any of them. And in this case, they open up in Dimensions simply because we set up the dashboard like that. So it's actually not too hard. Hold on, where am I going here? It's actually not too hard to build a dashboard like that using Dimensions, Google BigQuery, and a tool like Google Data Studio. You could do the same with Tableau, Power BI. I'm sure it would be pretty similar. And so if that's the sort of thing you're interested in, I think a really good starting point is this sort of tutorials on our main documentation page. Okay, right. Since we are on the docs, the only other thing I think it would be useful to point out is this section here called data source tables. So for those of you who come from the Dimensions API experience, this is very, very similar to the API. Essentially, this is a full list of all the fields we have available in these data products. For example, if I click on the publications section, I can see the full list of fields available in GBQ for Dimensions publications. So the field names, 99% of the cases will be exactly the same as the API field name. So if you have an API query, it will be easier to transform it into a GBQ query and the other way around. So for each field, there's some documentation. We even have examples here that show you exactly how the data look like in GBQ. And so this is this should become your friend. You should start building, GBQ queries. You should really familiarize with the data model and the fields available in our data set. Okay, so today's hands-on session. All right, so I prepared a little Colab notebook. So Google Colab is a cloud-based Jupyter environment. Essentially, it's a bit like a Google document. If you do not know what these things are, it's a bit like a Google document that allows you to run code as well. So you can mix text with code. And so it's a really handy way to test things out when we're talking about APIs and data processing. So I prepared this notebook. It contains a bunch of queries we can look at. Many of the queries I'll be showing you in the notebook, as well as the Google BigQuery console, which is another key resource to keep in mind if you start working with Google BigQuery. So there will be a bunch of queries essentially showing you how to build the publications data set behind that dashboard I showed you a minute ago. Essentially, we were putting out all the publications metadata from the public COVID-19 data set in a way that makes it actionable by a dashboarding tool like Data Studio or Tableau. So we'll be looking in particular at the concept of repeated fields, which is something which is not traditionally found in relational databases, something which is very specific to Google BigQuery. So we'll be looking at those and see how we work with them. And then we'll be looking at the DSL, the API. In particular, like I mentioned, the DSL allows you to search the full text of all the documents in Dimensions. Google BigQuery is more like a structured metadata database. It doesn't contain the full text. So a very common use case is to essentially define your own corpus. You may have a few keywords you want to use. In some way, you define a set of documents you want to look at. And then based on the set of documents, you want to essentially use that result set in Google BigQuery to then run some more sophisticated analysis using SQL. So we'll be looking at how it's possible to essentially run a DSL query to create a new table in Google BigQuery and then use that table in combination with the rest of dimensions to derive some more interesting analytics. So that will be the final thing we'll be looking at today. Discussion, that's too early for discussion. So I guess what I have to do now is move over to the notebook. All right, let's bring it up here. All right, so let me go up at the top. Here we go. Okay. So very first thing you probably have to do every time you try to access BigQuery from an external system like this notebook, or it could be your Python script, or whatever language you're using script, is to authenticate with BigQuery. So if you use Google Colab, it's actually super easy to do it. So the way you do it, I'm going to reconnect here. The way you do it is simply to import the Google Colab library here. By the way, I'm using Python in this. So you import the Google Colab library and you run the method authenticate user. Simple as that. And then I'm loading here a Google Cloud BigQuery library that will make it easier to run queries in the following cells, essentially using the simple syntax where I simply say BigQuery at the top here, and then I put in a SQL query right away. So I'm going to run this, and oh, okay, I was already authenticated, so let me see if I can actually authenticate again so you can see how that works. I've never done it before. Let me see, I can do restart runtime. That should be enough. Essentially now I'm resetting, in theory, the status of the cloud server behind this notebook, but of course the authentication is still there. Okay, let me try and rerun. Oh, I know what I can do. I'm gonna open this up again here, and in theory it will log me out. Let's see. No, okay, Google is too clever. There's no way to get around it. But fundamentally, what would happen here is that you will be given a link. You have to go to, at that link, you would log in using your Google credentials. And once you're logged in, you're given a temporary password you can use to authenticate within this notebook. So it's a very, very straightforward process. Everything happens online. You don't have to do anything. You don't have to store any password or anything like that. So once you're authenticated, you can actually start querying. Yeah, and sort of what I'm doing here, I'm essentially using this magic command. Essentially, it's a bit like a shortcut. This it means whatever you find in this cell here, it's a SQL query, so send it to BigQuery directly. I pass my project ID, so whenever you work with BigQuery, you need to be within a project. Yeah, that's one fundamental concepts of BigQuery. So in my case, that's what what's my project is called. The very first time you set up Google Cloud, you will be asked for a project name, so you need to make sure you put your own project name in there. So what I'm doing here, I'm essentially querying the COVID-19 data set, and I'm saying count all the objects I have in that data set. And that comes back at the moment with 191,000 objects, and these are publications. So I'm looking at the publication section of the data set. So I can run queries from here, but as I mentioned, the Google Query Console, that's another resource which is extremely useful when you try things out. And also when you build applications, just to see what the data look like. So the console is fundamentally a query interface for Google BigQuery. If you don't find it on your GCP page, you probably have to scroll down a little bit here. As you can see, there's many options. These are all different products Google has to offer. And I think if you scroll down, you get to big data, you'll see BigQuery right there. After you've done it once, it's a good idea to click on the pin symbol there, and then BigQuery will appear up there at the top every time. So what I see down here, these are all the different data sets I have access to. So the COVID-19 data set, that's the public one I was telling you about. a few moments ago. And as you can see here, I have the publications table. I'm going to bring this up a little bit with all the publication fields. I have the grants table with the grants fields and so on. So these are all the different data you can access for free using this public COVID-19 data set. So my query here essentially is counting all the objects in my publication table. So if I run the same query within the console, there's a few extra things you get from that. I still get the results back. I can see the raw JSON data coming back. There's some execution information you might be interested in looking into. It tells you also how much data the query is processing, and that translates into costs. Of course, this is nothing. This is 0 bytes. It will be, I don't know, 0.0001 cents, something like that. I have no idea, but it's really very, very little. But in some cases, you see some of the queries we run afterwards, they may be consuming 1 gig of data, because essentially you are touching a lot of different data points in your data set. So in that case, it will be a bit different. So the other thing which is useful about the console is that you can explore, you can save the results very easily. So if you have some interesting query, you can export the data CSV, JSON, you can export it into another BigQuery table or to Google Sheets. So these are really, really handy functions. The moment you know how to pull data you're interested in, this makes it really easy to reuse the data within some other environment you're familiar with. Right then, so I'm gonna go back to the notebook here. So we have seen, so there's 190,000 publications in the COVID-19 data set. Of course, we know that's a really, really hot topic now. And so we want to try and look at is how many publications we have every month, just to see whether the numbers go up or not. So what I'm doing here, essentially, I'm using the field data inserted from the publication dataset that tells you essentially when that specific record was added to dimensions. And I'm using these fields to group my results. And in particular, I take the month and I try to group the results by month, looking only at 2020. And that should give me an idea of how many publications were added to the dimensions about COVID-19 every single month, and that's the data I get back. So the reason why I brought this query over here is because the other feature which is really nice about the console here is that you can move the data pretty easily to a visualization tool, in this case, Data Studio. So you don't have to be a Data Studio expert. Data Studio is fundamentally a free visualization tool from Google. So you don't have to be an expert about Data Studio to build some very simple visualizations with it. So here I pull the data into the system, and then let's just say I want to build a bar chart that shows me essentially how many publications I have every month. Okay, so in this case, I've selected the chart. Clearly, things are not looking right because they all look exactly the same. And then I'm just going to skip a few steps here, but just give you a feeling for how it works. So this visualization, they normally have two menus: dimensions and metrics. Dimensions are essentially the segmentation. What are the things you display on your chart? In this case, that's the months. And metric, that's the quantity you want to display in your chart. In this case, I'm showing how many records I have every month. But that's not really what I want to show, because of course I have one record, which is one number. I want to show the total publications per month. So I'm going to get rid of the record count, and this looks a little bit better. And this is not sorted correctly because I'm sorting by record count. I don't want to sort by record count, but by month and ascending. There you go. And so this essentially is a visual representation of how many COVID-19 publications we have every month in dimensions. All right, so that's Data Studio, and that's essentially a very quick way to build charts from the results of your query by using this console menu, Explore with Data Studio. Now, moving on. So what we're gonna try and do now is extract some, I would say, standard publications metadata from dimensions on BigQuery. By the way, I'm using here the COVID-19 dataset simply because you can see it as a slice of dimension containing only documents related to COVID-19. All the rest is exactly the same. So the fields you will find in there, the structure of the fields, everything else is exactly the same. So it's a really good data set to get the hang of the data model, to try things out and see, how dimension was structured. So what I'm doing here, essentially, I'm saying, look at the publications table, just pull out publications where the date inserted is 2020, and for each of these publications, I'm extracting a bunch of, standard fields like the ID, title, DOI, journal title, and publication type, and so on. So I'm gonna run it now. So that's what comes back. Not too surprising. Something else that you probably find out, maybe not here, but if you keep scrolling, if you get more data, is that often we don't get a title here in journal because, not all publications are journal publications, obviously. There might be some books or some other sources in there. So we can, work around that problem by changing the query a little bit here. So I'm using a function called coalesce, and that essentially takes the first non-null value from a list of fields. So essentially what I'm saying here, for every record, if you find a journal title, take that, otherwise try the proceedings title, otherwise the book title, otherwise the book series title, and so on. So that allows me to always get a venue title. By the way, I'm renaming that to venue in my results. So that's a small update to the previous query, which will be handy, if you're trying to produce data you want to reuse in some dashboard or something like that. So I'm not going to go through, of course, all the many things you can do with SQL. This is not really the place, and there's tons of tutorials online. But one specific topic which I think is important to point out and for you guys to spend some time on is this notion of repeated fields. So if I'm going to go back to my console here, if I open up publications, all right, so we scroll down the list of fields. So you will see that the column is called mode. You have two columns, type and mode. Yeah, type is a basic data type for that field. String, is a text. Title is record, meaning that's a structure field. So it's a bit like a container. So you wouldn't pull out title, maybe very often. You probably just say title dot preferred. You want to get something inside title. Now, if I keep scrolling down, you will see that there's other fields that were in modes. It doesn't say nullable, but it says repeated. Yeah. For example, researcher IDs or research orgs. So this is a bit different from traditional relational databases, where if you have a relationship between one object and many other objects, you split this up into different tables, and then you add links. You have some many-to-many or one-to-many relationship between different tables. In BigQuery, things are a little bit different. So you have this notion of repeated objects, meaning that you can have different objects within the same record, so to say. And so we can look at that actually in practice very quickly here. So what I'm saying, essentially, I say select research orgs. So I'm pulling out some examples from this repeated object here. Actually, I'm going to say DOI, comma, research orgs from my COVID-19 data set. That line is not needed here. That's only for the notebook. And there we go. So as you can see, some publications, they don't have any disambiguated research organizations, but some others like this one, as you can see, I have one row, but there's two objects under the research organization. That's because this object has been nested inside. And that's fine. It makes essentially, it's a very good way of save space, and to achieve performance on other fronts. But of course, the moment you want to process this data, for example, if I want to pull out the, I don't know, I want to look at how many publications every organization has, I need to extract these objects from this nested structure. And so the way you do that is by using this specific command called unnest in Google BigQuery. And what that does, essentially, it creates an extra row for every object I have in my nested structure. For those of you with a SQL background, it's a little bit like doing a join on another table, a cross join, because you merge these two objects together and you generate new rows. So let's try that again here then. So here I'm essentially the same exact query, but I'm saying unnest the contents of this field here, research orgs. I give it a name, same name as before, it doesn't matter what name you give it, and then I'm gonna run the query. So as you can see here, there's no nested objects in there anymore, right? And in some cases, I have the same publication appearing in two rows, yeah, because I'm kind of exploding essentially the contents of this field. So the concept of this is actually, I think, is quite simple. I mean, it's quite straightforward. But when you have more complicated queries, you know, this whole nesting business is something to pay attention to because things that can get complicated pretty easily. Right. So a slightly more complicated query here. So here I'm essentially having the same unnest operation. I'm pulling out all the research organization identifiers, the grid identifiers. But of course, you know, identifiers are not very, you know, pretty. It's hard to make sense of them. I want to also look at the names of these organizations. So the way I do that is by doing a join on the grid database. So publications have contain information about organizations, but the specific details of organization, they are in the grid database within the data set. And here you find information about, you know, name of the organization, geolocation codes, relationships, external identifiers, all sorts of things. So this is another very common operation when you work with dimensions data. And so the way I do that is essentially by joining up the two tables. Yeah. So here I'm pulling out these grid identifiers, and then I say join these identifiers on the grid table using the ID field in the grid table. And here we go. So what I'm getting back now is a list of the organizations linked to the COVID-19 dataset and the name of each of those organizations. Right. So next step here in the tutorial, we're essentially putting together the basic metadata query we built before with this extra bit about a nesting organization. So I have a list of publications here. Some of them are repeated, but for every publication, I also have the organizations representing the affiliations of the authors, including also country and city information. Now, further step here that I'm going to actually skip because it's essentially the same concept. So in this step number 5 here, I'm nesting another two fields, categories and open access information for every single publication. Is this exactly the same approach? You know, I have this unnest operation on categories and open access categories because these categorizations, you know, there's many of them for every publication. And so you need to do this extra step if you want the data to come out in an actionable way. So I'm going to copy paste the query there just to show you what it looks like. Once again, I have my list of publications coming through, and if we look down here at the very end, so you can see we have open access categories, and there is no field of research categories for some reasons, maybe because at the very top, I'm getting only the publications without a category, but trust me, they're there. So you can try that out yourself if you're interested in pulling out this information, but the basic message here is this special attention you need to give to this unnest operator. Good. So we're getting now to the final part of the tutorial, and this has to do with the API and Google BigQuery. So why would you want to use both? So the fundamental, there's different reasons actually. One could be you need more data. So the DSL has some limitations, yeah, especially when you're using the faceting approach. So for example, you have a publications query and you want to get the researchers related to those publications. So with the DSL, it's very, very easy. Actually, I'm going to show you that for those of you who do not know the API. Here, I'm just simply logging in the Dimensions API package. I'm loading that and I'm logging in. So now I'm logged in. I can try a few queries. Yeah. So in this case, I have a little query that searches publications for this full text string. Moon landing, moon and lunar surface. I was trying to put together an example about moon landing, so I came up with this search term. There's an error there. Search publications, return publications. There's 11,000 publications. I'm getting back the top 20. Say I want to know what are the top researchers related to these publications. I can facet on those results and say return the researchers. And that works, but it works only up to 1,000. Yeah, there's a hard limit on the faceting operation of the API. So it's really fast to pull out this data, but you can only do it up to 1,000. So if I say 1,050, it will throw an error. And likewise, I can't even say limit 1,000, skip 50, that will also break. So what if I want to have a look at all the researchers related to my publications? The only way to do that is to pull all the publications data manually and then write something in Python that processes the publications and then analyzes the researchers. Some of you have probably been doing this and know what I'm talking about. So that's one limitation. You want to get more data quickly. Another reason for essentially moving from the API to GBQ, you want an easier integration with other tools. So for example, I want to run a full text query using the web or the API, and then I want to use those data to build a dashboard. Similarly to the COVID-19 dataset, you may want to build a dataset about, I don't know, electric cars in the US. So there's a few million publications you want to look at. You want to move them to GBQ to build dashboards only on those publications. And finally, the other reason why I want to move from one environment to the other is to get richer data. So for example, I have these researchers related to the corpus of publications I'm interested in. And I want to add other information about this researcher. So for example, other researchers' metadata or citations or metric statistics for each of these researchers in relation to the data set they belong to. So all of this can, of course, be done using the API and Python, but that's a lot of processing you have to do yourself once you get the data back. It's like having all the data in an Excel spreadsheet and then having to slice and dice the data in multiple ways to start counting. And sometimes that also means many other queries to the to dimensions via the API. Now, if you have the original data set in GBQ, there will be one single SQL query. Yeah, you can do all of this with one single query, and I'll show you how to do that. So the very first step, I think, is let's just assume we are trying to build a corpus which is relevant to us. I have dimensions open here. I'm gonna say I want a corpus about moon landing. So I'm gonna search for moon landing in the full text. I want some other keywords to make my results a little bit more precise. I'm gonna say moon landing. I'm gonna add moon as well with an and I'm gonna add lunar surface with an and. So my query could look like that. So I have moon landing and moon and lunar surface. Okay, so let's just imagine that is a nice search string for defining my data set, right? So what I get back here is 11,000 publications. And let's just then imagine I want to recreate some of the analysis I see here on the analytical view. So for example, if I look at researchers, I can see here a nice table showing me the top researchers, how many publications they have within this corpus, how many citations. So that will be my starting point, but I want to have other columns like how many, what's the total sum of all metric scores they get, and possibly even other stuff. So the way to do this is to essentially take this data set here, move it to GBQ, and then use the power of GBQ to calculate all of this information in real time, also by using the rest of the dimensions data set. So I'm going to take the full text search string here. I'm going to go back here, and well, of course, I was trying this earlier, so already have it here. So the very first step, I'm running a full text search with that specific string using the API, and I'm saving the results as a data frame. So this ugly command there, that's essentially a nice shortcut that allows you to run a DSL query within the cell. It is not just a simple DSL query, it's an iterative query, meaning that it will keep querying the API as for as many results as you can find. So we'll keep going until it gets to those 11,000 records. And then the little df at the end means turn the results into a data frame. A data frame is a bit like a Python spreadsheet. Yeah. Right. And in this case, essentially, we're not extracting from the API all the metadata about publications. We're only pulling out the IDs, and I'll show you why. Well, fundamentally, because the IDs, that's the only thing you need to merge this data with the rest of the data in BigQuery. So here I have essentially a big table of publication IDs. There's more than 11,000 of them. So the next thing I need to do is to move this table to GBQ. That's actually super simple because Pandas, that's a popular Python library for data processing, has a command called toGBQ that allows you to move data over to GBQ one single line. So I'll show you how that works. So every time you run a magic command with the DSL, with the API, the results are stored in this variable called DSL last results. So I'm going to move that variable to this new variable called df. And then I'm going to say that's my data set name in GBQ. Within the data set, I'm going to create a new table called moon landing. And then I simply say move that data frame to GBQ within this table name. That's my project ID, the usual project ID. You always have to keep in mind when you do this stuff. And then I say, if the table exists already, just replace it. It does exist because I ran it before, but now we're going to run it again. And as you will see, this is going to take seconds. There you go. That's all done. So if now I go back to my console, I'm going to close this up. That's the project I was focusing on, DS Data Solutions. That's the name I gave it. And Demo DSL Moon Landing, that's the table I just created using the DSL results. As you can see, there's only one column, ID. If we preview it, it's a long list of publication IDs, right? So that's all we did. So what are the next steps? Fundamentally, the idea here is that you want to select all the identifiers you have in that table, join them up with the rest of dimensions to capture all of the extra metadata dimension knows about those IDs, and then perform operations on top of that new data set. That's the fundamental approach, right? So if I run this query here, for example, essentially what I'm saying here is select everything from the main dimensions table about publications, join that table with my DSL expert with those 12,000 results I just exported using the ID field. And all of this is essentially saved to a new temporary table, a memory table called my publications. So essentially that's my dimensions view, that's my view of dimensions for my specific corpus. And once I have that, I can carry on and do any sort of analysis I want because I essentially exported my view of the data into GBQ. So for example, what I'm doing here, I'm sorting by year. I'm grouping by year and sorting by year. As you can see, 2003 has 100,000 publications. Once you do this sort of exercise, it's always good to go back to the web interfaces to make sure things are actually correct. So if I now remember in a web interface, I'm searching for a moon landing and blah, blah, blah. So if I open up the publication year facet and I click on more, I should be able to see that 2003 has, that's 10,052 actually. It wasn't 100,000, 10,052. So numbers match up, yeah, meaning that, you know, things are actually working out okay. So that's a very basic step, I would say. So the other thing that becomes, you know, possible once you have all the data in GBQ is that you can start building statistics very, very easily using, you know, the full range of data sets of data that you have in Dimension. So for example, I told you how pulling researchers' information specifically for this data set can be a little bit difficult with the API because it involves different steps. With GBQ, essentially, all I have to do is, you know, once I have my view of GBQ based on my corpus, I can simply start saying, you know, group by researchers in this specific corpus. I can count how many publications I have per researcher. I can count the citations per researcher. I can count the all metric information. Yeah, I'm using here this unnest operation, the one we looked at before, just because, of course, every publication has more than one researcher associated to it. So I need to explore that information. So using the simple query here, I can very quickly get to a view like this, where I have the full list of researchers for my corpus. There's 1085, and I have some metrics associated to them. And just like before with grid identifiers, these identifiers are not really user friendly. So the natural next step would be to add another component to my query here. So these two steps are exactly the same as before. So I get to a list of researchers with some metrics. So the next step would be, once I have the researcher identifiers, I do two new joins. Yeah. First one would be on the researchers table. The researcher table contains all sorts of information about researchers, like current organization, first name, last name, and blah blah blah. And then the grade table, because once I get the grade organization, I want to get information such as city, country, possibly some geolocation information if I want to visualize the data, and so on. So I'm adding here an extra step saying enrich that researchers table with new information, and I'm going to run it now. And as you will see, with one single query, I'm getting a pretty rich description of the researchers related to my corpus. And just once again, to make sure things actually do add up, we can look at the first guy here, Roger Lonius from the Smithsonian with 11 publications. And now if we go back to the web app, open up the analytical views, open up researchers, and here we go. And that's it. Roger Lonius, Smithsonian, 11 publications. So we were able to recreate this query and adding a bunch of other information and stuff. You can keep adding stuff to it very quickly. And so that the data, once they're formatted like this, you can export it to Tableau. You can build charts using it. You can do all sort of things, and that can be done really, really quickly. I think it's 4 o'clock sharp, so I'm gonna stop here and see if there's any questions before saying anything else. Any questions? People, feel free to add stuff to the chat.
Can you see the question?
I can see it. Okay. Jen Lee, okay. Is the category FOR can be mapped with the ASGC codes for publications? You get me unprepared there. I'm not sure. I'm not familiar with those codes. Maybe Christina, do you know anything about it?
Yeah, I Googled them. Okay. I might be wrong, and correct me if I'm wrong. They are the Elsevier journal level categorization. And there are some differences to the way we approach categorizations in Dimensions and the way other databases approach categorizations. And that is, we apply the categorizations at article level. So what you would see at a journal level is actually an aggregation of all of the categories that their articles have fallen into, rather than the other way around. However, I guess that if you have the definitions for the ASJC, you can always just match them together in a separate environment, like the Jupyter Notebook.
Yeah, I'll be surprised if no one's ever done it before already. So Jen, maybe why don't you follow up with us, send us an email, and be very happy to look into it. Next question about a nest. Is a nest applicable in Python or just BigQuery? Yeah, essentially, yeah, that's a good point. So you have an nest operator command in Google BigQuery, in the SQL of Google BigQuery, but there's also an nest operator in the dimension search language, in the API language. They work in a similar way, but also very different, because one is SQL, the other one is our own API language. Let me see. Here we go. It's a very hold on. That was my son coming back from school. Obviously, he comes and tries to give me a hug. Very first thing. So yeah, what was I saying? Yes, the nest operator in the DSL. It's a similar concept. So what you see here, I'm searching publications, returning publications, and unnesting researchers. So very similar concept, but you always have to keep in mind that on the one hand you have SQL, on the other hand, the DSL is our own search language, which is similar in some ways, but it's also simpler in many respects. Then Jan was saying researcher metric, very useful. Right, okay, fantastic. Great. I don't see other questions, so maybe we should just say goodbye and hopefully see you soon. We have another training coming up in a couple of weeks. Is that right, Christina?
Yes, the next one will be focused on open access analysis in my very favorite environment, which is Google Sheets.
Lovely. Yeah, looking forward to that. Okay, thanks so much to everybody for attending, and please do get in touch if you have ideas, feedback, or questions. We'd love to hear from you. All right. Bye-bye.
Thank you. Bye. Have a lovely afternoon or morning, wherever you are. Bye.